This is for Year 12 Specialist Maths, and it's how to draw the graphs of sec x, cosec x, and cot x, and how you can do it on a calculator. Remembering that sec of x is just 1 on cos of x, cosec of x is 1 on sine of x, and cot of x is 1 on tan. So it's the reciprocal or inverting the cos, sine, and tan graphs. Don't get confused that it's the same as the inverse. And there's a little similarity in the way that we write them, but this is actually in sec's case, it's cos of x, the function, raised to the power of -1, which is 1 on the cos of x. Okay, what does cos of x look like? Got an axis there. Cos of x has a period of 2 pi, has an amplitude of 1, therefore it will start at 1 and then it will go down to -1 at pi, it will go back up to 1 at 2 pi, and it will complete that cycle and continue going down to -1, going back up and finishing at 1 again, and that cycle continues. The coordinates there, or the y coordinate, is 1, and the y coordinate there is 1, and the y coordinate here is -1, and the y coordinate here is -1. And at these points here, the y coordinate is 0. So that when I'm trying to calculate what sec of x might look like, it's actually going to be 1 on cos of x. So it's going to be 1 divided by whatever the y coordinate at that point was. So if I was to have a little look, this point here, 1 on -1 is still next up with pi, 2 pi, 3 pi, 4 pi. So at -1, it's going to start at -1. At x equals 0, 1 on 1 is still 1. At x equals 2 pi, 1 on 1 is still 1. When x equals 3 pi, I'm still going to be at -1. When x equals 4 pi, I'm still going to be at 1. The problem that I have at pi on 2 is 1 divided by 0 doesn't exist. So in actual fact, at pi on 2, I have an asymptote. I have an asymptote here at 3 pi on 2. I've got an asymptote at 5 pi on 2 and 7 pi on 2. And as x approaches here, this is going to be a really small y value. Therefore, 1 on a really small y value will give you a value approaching infinity. So in actual fact, I get curves that are looking like this. This is what the graph of sec of x will look like. I'll have asymptotes, and I'm going to have curves that approach infinity. What might it look like on the calculator? Okay, so if I bring up the keyboard, math trig cos of x, and I change my window identically the same as what I had there, so from 0 to 4 pi. Okay, graph. And that's the graph of what's in red. if I take one divided by the cos of x, here are those curves that are drawn here in blue. What would cosec of x look like? Remembering cosec of x is 1 over the sine of x. If this is what the graph of the sine of x looks like, remembering that it continues and continues, then cosec will be the reciprocal, or 1 divided by the y value. Okay, so the y value here is 1, so that stays at 1. The y value here is -1, so that stays at -1. That's 1, so that stays at 1. That's -1, so that's -1. Here it is 0, so I'm going to have an asymptote at x equals 0. I have an asymptote at x equals pi. I have an asymptote at x equals 2 pi. An asymptote at x equals 3 pi. And I'm going to have curves that are similar to what I had when I graphed sec of x. Remembering that these points here will be pi on 2 and 1. 3 pi on 2 and -1. 5 pi on 2 and 1. 7 pi on 2 and -1. Would the calculator give the same answer? I untick these and I make this equal to the sine of x. And I make this one equal to 1 divided by the sine of x. And there's the graph of my sine of x, and if I add 1 on the sine of x, and I make that, and I graph them both, then we end up with what we have here. And if we consider cot of x is 1 divided by tan of x. Looking here, I have a graph of tan of x, where the period is pi. I'll have asymptotes at x equals pi on 2, x equals 3 pi on 2, x equals minus pi on 2. When drawing cot of x, it's going to be the tan value, the y value of tan, inverted, or the reciprocal. So I'm going to end up having 1 divided by the y value. So at x equals 0, tan of 0 is 0. So for cot of 0, I'm going to have an asymptote, 1 divided by 0. At pi, I'll also have another asymptote. At 2 pi, I'll have another asymptote, because the tan of 2 pi is 0. I'll have an asymptote at minus pi also. Remembering it's the inverse. At pi on 2, I'm going to have a 0. These are negative, whereas these are positive. So this is what my curve's going to be like. Okay, let's check it on the calculator. Tan of x, tick, graph, and there are my red curves from 0 to 4 pi. If I then and they're going to go in the opposite direction, and I will have asymptotes which are at 0, pi, 2 pi, 4 pi.